am D.T. Vimala, Assistant Professor, Department of Computer Science, working in St. Josephs College of Arts and Science for Women, Busu. Topic is Physical Surface Detection Algorithm, subject Computer Graphics. In this, we are going to see about the algorithm, that is a scanline method algorithm. The scanline method is a computer graphics rendering algorithm used to fill the polygons with color. It is particularly used for filling complex and concave polygons. The algorithm operates by scanning each horizontal line of the polygon and determine the intersection of that line with the edges of the polygon and fill the pixel position between those intersections. That means it first scans the horizontal line of the polygon. After that, it determines the intersection point, that is the edges of the polygon. After that, it fills the pixel position between these intersections. This is the method how the scanline algorithm works. First, the initialize edge table ET. The first step is to create edge table that stores information about each edge of the polygon. For each edge, the table contains information such as the y-coordinate of the lower endpoint, the slope of the edge, and the x-coordinate of the intersection point with the current scan line. Next table is initialize active edge table AET. At the start of each scan line, the active edge table is initialized to empty. As the algorithm progresses, edges are moved from edge table to the active edge table when they become active. That is, when the current scan line crosses the edges. Move edges to AET, that is active edge table. For each scan line, edges from the table whose lower y coordinate matches the current scan line are moved to the active edge table. The edges in the active edge tables are stored based on their x coordinate. Fill pixels between edges. After setting up the active edge table, the algorithm proceeds to fill the pixels between the edges of the polygon. It scans the pixel horizontally, determining which edges of the polygon intersect with the current scan line. It then fills the pixel between those intersection points. That means it scans a line, it finds the intersection point, edges, and then it fills the colors. Update AT. As the scan line progresses, the x-coordinate of the edges in the active edge table are updated based on their slopes. If an edge reaches its upper end point, it removed from the active edge table. Repeat these steps, that is 3 to 5, or repeated for each scan line until the entire polygon is filled. The scanline method is efficient for complex polygon and works well for both convex and concave shape. However, it may have challenges with handling vertical edges or horizontal edges with zero slopes. This is the scanline method, how it works. The scanline method is used for fill the polygons with the colors. Next algorithm is the A buffer method algorithm. A buffer is also known as the alpha buffer. The alpha buffer method is a computer graphics rendering algorithm used for hidden surface removal and anti-aliasing. It was developed to address some of the limitations of other algorithms like the edge buffer method, or known as a depth buffer method. The A buffer method is particularly useful in handling the complex scenes with transparency, overlapping surface, and fine details. The steps in A buffer method algorithm. Buffer initialization. A buffer maintains a list of pixels for each screen pixels. Each fragment contains information such as color, depth, transparency, and additional attributes. Scene rendering. As the scene is rendered for each pixel, the A buffer records information for all fragments that contribute to the final color of that pixel. The fragments are stored based on their depth, distance from the viewer, and ensuring that the frontmost fragments are processed first. Fragment sorting. Sorting the fragments based on their depth allows the algorithm to handle transparency correctly. Fragments with a lower depth are processed first and activating the final color of the pixel. That is, the fragment which has the lower depth, that is closer to the viewer, are processed first, that which affect the final color of the pixels. These are the steps in A buffer method algorithm. Alpha composing. For each pixel, the A buffer use alpha composing to combine the colors of overlapping fragments. The alpha value determines the contribution of each fragment to the final color. The final color of the pixel is calculated using this formula. Storage efficiency. To optimize storage, sparse data structure must be employed to store only the necessary fragments of each pixel. This is crucial for screens with a large number of fragments. Anti-aliasing. The A buffer method inherently supports anti-aliasing because it considers multiple fragments for each pixel. Smoothing effects can be achieved by blending the colors of fragments with different coverage. Memory requirements. While A buffer method provides accurate results for complex scenes, it can require significant memory resources, especially when the scene involves large numbers of pixels. Efficient data structure and memory management are important considerations for A buffer method algorithm. That means the A buffer method algorithms requires efficient data structure and storage memory management for A buffer method algorithm. A buffer algorithm is versatile and effective for handling the transparency, complex geometry and intricate details. However, the trade-off involves higher memory requirements compared to some other algorithms. Advanced in hardware capabilities and optimization technique continue to make a buffer more practical for real-time graphics applications. Thank you.